This is how to draw 5-103B, which gives us practice with revolve. Revolve is different from extrude because it allows us to take a closed sketch and wrap around this axis to make cylindrical shapes. So step one, we're going to start by drawing our center line of our axis at our origin. Then we're going to draw the 3 rectangles on one side of the center line and dimension all the vertical sizes. We see that the first one is 0.75, the second one is 2.25, and the third one's 0.5. So I've got my drawing. I'm going to create a new sketch on the front view this time. Hide my planes. And so first I'm going to start with my center line. To draw a construction line or center line, you want to turn on the construction button when you draw the line. And it doesn't really matter how high you make it, you want to make sure it's vertical. And I can turn that feature off. Now I said I'm going to draw rectangles that don't intersect the line to the side of it. Making sure not to snap anything on accident. So I have my 3 rectangles that are stacked, and I see the first one's 0.75, the second one's 2.25, and the third one's 0.5. Dimension edge to edge, 0.75. Dimension from bottom to top, 2.25. And the last one's 0.5. Again, I'm using the edge to edge method instead of clicking the line and dragging out. So I have all the heights dimensioned. Now we need to dimension the length. But since it's a round object, and all round objects are usually listed in diameter, that becomes a little bit harder to do if you have to do the math. Luckily, there's a feature built into Onshape that it does it for us. So we see the outside of our biggest rectangle is a diameter of 3.5. Since we drew a center line in our object, we can dimension from the outside of the object to the center line and then drag to the opposing side to get a diameter dimension. So if I go back and look at my drawing, dimension from outside line to center line, if I were to keep it on the left side of the line, I get the radius distance. If I drag past a center line to the other side of the object, it gives me a diameter symbol. So it automatically accounts for the distance on the other side of the object. And we said it was 3.5. I can see I drew it much bigger than necessary, and it shrunk it past the object. So if I need to, I can always drag it where I need to. Let's kind of reassociate some of my dimension as needed. Normally, I would actually recommend dimensioning the distance from the center line to your inner dimension if it's a tube shape, which is 0.75, and then dimension your largest outer dimension. So 0.75. Center line to inner dimension. .75. And it drug those apart, so let me just push this rectangle back outside. It really doesn't matter yet. So I have the inner and the outer. That's what matters. I'll fix these in just a minute. I can see the big outer is 3.5 in diameter. The second largest cylinder is 2 inches in diameter, and then the third largest cylinder is 1.5 inches in diameter. So dimension. Oh, I see I messed up because I dimensioned this as 0.75 from center to inside instead of diameter. So let's go fix that. Give you practice on having to fix your dimensions. Oops. Edge to center line, drag past the center line to make sure you get the diameter dimension. That looks more appropriate. So this one was a distance of 2 and then 1.5. Center line to edge, past center line, diameter of 2, center line to edge, past center line, diameter of 1.5. Once you've locked in that dimension, you can then drag the numbers where they stack nicely and look a little bit neater. So it's easier to identify your parts. Now the portion I'm missing is on the inside here. I could revolve this whole shape and then create a new sketch and do a revolve remove if I wanted to make sure things didn't get messed up. Or I can just draw the portion I don't want and remove it that way. I can still see a lot of blue lines and dots in my drawing, which means something isn't constrained. So if I click on one, I can probably drag it around and find out what's not constrained. I can see it's because I didn't constrain it vertically to the origin. And that can be easily remedied by just doing a horizontal constraint from the origin to the corner of my object. It's not necessary, but it just turns some of your lines from blue to black to fully constrain them. Now if I go back and look at the inside of my shape, I can see that there's a taper missing on the inside that has an internal diameter of 1.25, a height of 1.5, and then a slanted piece to fit a threaded pipe or something inside at 15 degrees. So 1.25 and 1.5. So I'll just use create a rectangle to do that with. I don't need this dimension here, but I could plug this dimension here since I know that's 1.5. Again, I'm going to dimension from the inside edge to the center line and drag to the left or to the right so that I can get it as a dimension. We said that was 1.25. Now I have an angled line that slopes towards the center, and I want to make sure not to grab any center midpoint snaps on accident, so I'll exaggerate it. And then I see that it is 15 degrees from vertical, so I need to pay attention to that when I dimension. Dimension, angled line, vertical line, and I want to make sure it's 15 degrees between the two. So now I have all my dimensions done, and I can choose what to revolve. Revolve. And I'm going to go ahead and unselect by clicking the X for the parts that it chose for me, because that's not what I want. I can go ahead and click my revolve axis because I know that's going to be my center line. Now I can click inside the faces or regions to revolve, but I want this outside base rectangle circle. I want this slanted part here, and then I want the top. I want to make sure not to have clicked the inside region that was removed and the slanted line. That looks okay. I want to do full circle and say okay. So I drew the rectangle and angled line representing the internal taper, dimensioned it vertically at the angle, dimensioned the cutout with the diameter dimension. I revolved it, making sure to remove the internal taper. To show it so you can actually see the sketch, you can use the section tool to remove part of it so you don't see it. So for example, if I roll over or turn back on my front plane and my right plane, which cut through the center of it, I can section it that way to see internally the inside of it. So section view, front plane and right plane, and I can either grab that part of it, or if I grab the wrong piece there, I want to grab the other axis, that one. You can see it'll give you certain ones to remove. If I don't want that, I can just remove that section plane, and then I can turn my sketch back on and show the dimensions. And that's normally how you would portray it in your notebook, so I can see it's a revolved object. It shows it's being sectioned by the cutting plane lines here in the inside, and I can see the dimensions. Thank you for watching.